Hello, Clay County. Today we're going to address one of the pillars of evolution, and that is the pillar of time. All throughout the textbook, in this one and any of the other ones that you read, the evolutionists will claim that the Earth is 4.5 billion years old, that the universe is 13.7 billion years old, and that evolution must have millions of years of time to happen. And they talk about all these common ancestors that we had with apes and with um, dogs and with plants and with fish and all of these different things that we all came from this common ancestor millions and millions of years ago. The problem with that is they just don't have enough time. And we're going to talk about that today, and we're going to talk about blue stars. I have a video here from phet.colorado.edu. It's a physics simulation that you could do, or I think it's actually under the chemistry section, under gas properties. And what this is you have an enclosed chamber, and you pump it full of gas, and we're going to get over 1,000 particles. You can see over on the right hand side where it says light species, we're up over 1,000. And then we're going to take the lid off, and we're going to see that all of those molecules just expand out. They just leave the container as they expand out. And we know this happens. If I were to take a jar of, let's say this was poisonous gas, and I were to take the lid off, I would be dead pretty quick, because the gas would expand to fill the available space. It wouldn't just stay in the jar unless it was heavier than air. And so that's what gases do. We all know it. Gases expand to fill the available space, and they don't contract. There's nothing about them that pulls them together. Now, I have some numbers here. This is taken from the University of Illinois professor there named James Kaler. He's the professor emeritus of astronomy, and he said that the Earth's atmosphere contains 19 quintillion molecules per cubic centimeter. This is a cubic centimeter, just a dice. And if you look at our atmosphere at sea level, it contains 19 quintillion. That is 19 followed by 18 zeros worth of molecules in that amount of space. And then he goes on to say, for nebula, as bright as many nebula seem to be, they are very rarefied. Densities range from a maximum of about 1,000,000 atoms and electrons per cubic centimeter, only 1,000,000, not 19 quintillion, for the most compact objects, down to only 10. So there's 10 atoms of mostly hydrogen inside this cube. And that's for the huge ones that are dissipating into interstellar space. Get that? He agrees that the nebula are dissipating into interstellar space. They're spreading out, filling the available space after the supernova that supposedly formed them, which I don't have any problems with that. But after the nebula forms, it just keeps expanding. The explosive force of the star, the vacuum of space, the gas just expands and expands and expands. He says, by contrast, the air you breathe has the 19 quintillion molecules per cubic centimeter. The nebula gas would in fact make an excellent vacuum in the physics lab. Were you inside a planetary nebula, you would not know it. It's so sparse. You could stand inside of it. Now when we see pictures of these guys, we're way zoomed out. And so we're seeing it all together, but it's actually so sparse inside the nebula that if you were inside of it, you wouldn't see anything. You would look like you were in empty space. And these things are big enough that they take up several solar systems. So that's huge. The next thing I want to talk about is the comparison of electromagnetic repulsion to gravitational attraction. The gravitational constant, 6.67 times 10 to the negative 11, is 0.0000000000667. It's a tiny number. Conversely, electromagnetism's constant is 9 times 10 to the 9th. That's 9 followed by 9 zeros. You can see here the comparison, how far apart they are on the decimal line here. If you take the gravitational constant and you divide the electromagnetic constant by it, you end up getting a number that is 135 quintillion. 135 quintillion. Now, that's the second time I've used that descriptor, the quintillion. What does that mean? Well, 135 quintillion is like taking the United States national debt of 20 trillion and multiplying that by 7 million. It's a huge number. That means the difference between electromagnetism and gravity is enormous. It is mind-bogglingly strong. If electromagnetic repulsion, remember the nebula are 90% hydrogen. You got diatomic hydrogen. They do not attract each other. They hit each other and then they bounce off and then they expand into space. If you have the repulsion of these gas molecules, their electrons are pushing away from each other, what you end up having is a force that is supposed to be 135 quintillion times weaker, pulling all of those molecules in together and forming a new star. And that is completely unbelievable. It's ludicrous. It's ridiculous. And it doesn't matter how many times you read a Wikipedia article about nebula and protostars and new stars, or you go to NASA, or you go to space.com, or any of these articles, note that every time you read anything about the formation of stars, the language is either talking about models, or it's talking about may, might, could. All of these things are speculation, and the underlying foundation for their claim to this is that they must form, stars must form for the universal evolution, or they sometimes say galactic evolution, to occur. They assume that the universe, that the galaxy is evolving, that it's changing, it's coming from the Big Bang into what it is now and moving on into what it's going to be a billion years from now or whatever. And that requires the formation of new stars in their ancient cosmology. But they just assume it. There isn't actually any observable evidence, and part of the reason for that is for these types of things to happen, you can't just watch them in a day. You don't watch a nebula collapse into a star in a day and then boom, there it is. And even a lifetime of a human, or even the lifetime of humanity. There's no way that these types of things are observable. We've only had telescopes since Galileo, since the 1600s. And we've only had really good telescopes for about 100 years. And the really super space telescopes like Hubble, even less. And so our ability to view these things has been very limited in the amount of time. And so we haven't actually ever observed a nebula forming a new star. On top of that, everything that we observe is something that takes so long to happen that the only thing that they can do is make assumptions and draw conclusions based on the paradigm that the universe is very, very old. But we can show in a simple physics demonstration that that's not what gases do. They expand out. They move out to fill all available space. And if that's the case, the nebula never do collapse into new stars. There's no new stars that form. There's no evidence for it. There's just speculation. No new stars forming leaves us with a problem in terms of time. That brings us to the idea of blue stars. Blue stars are very, very bright, big stars. They are 200,000 times larger or more massive than our sun. And so they are brilliant, enormous stars. But they're also burning through their fuel very, very rapidly. Our star is estimated to have around 10 billion years worth of fuel left in it. So it's not going to die out anytime soon. A blue star maximum, the one with the most amount of fuel left or whatever, has about a 1,000,000-year lifespan. Well, that's a problem, because if there are still blue stars in the universe and no new stars form, the maximum age of the entire universe is 1 million. I'm not saying that's what it is. I'm not saying that the universe is at least 1 million years old. I don't believe that. But when we're just talking the science here, the maximum age based on our understanding of nebula and gases and blue stars, the data that we actually have that's empirically measured, because that's what we're going for in science, right? In the science classroom, the empirically measured data shows that blue stars do not form, no new stars form, nebula do not form them, and blue stars still exist even though they only have a lifespan of about 1 million years. So that outer edge of time is not anywhere closely sufficient for the time spans that the evolutionists need for evolution to take place, for all of the things that they claim to have happened. They just don't have enough time for it to have happened. And so it's devastating. It's one of the most devastating arguments that I've encountered for evolution, because if you take away all their time, they don't have anything. All they have is some little paltry experiments that all have failed. The Miller-Urey experiment, or the one with the E. coli bacteria that was just completed after 30 years, and they got nothing but E. coli. They observed no new information. They have all of these experiments that have ended in failure that are empirical science. But when we get outside of the empirical science, when we get into the historical science, where we talk about things that are beyond the lifespan of a human or the lifespan of humanity, then suddenly we have to just believe them because they're scientists. When we can demonstrate through empirical science that they're just making assumptions based on the conclusion that they want to draw. So I hope this wasn't too long, and I know that this is probably going to have a lot of questions. If you learn this one's really a showstopper in conversations with evolutionists. If you want to have conversations with these guys, bring up the idea that nebula don't form new stars, and the blue stars have very short lifespans, and so there's not enough time for evolution. And you watch them; they don't have anything to say, and it's science. It's observable empirical science that you're bringing against their speculation. So I hope this one helps. And until next time, thank you guys for watching.